Guys, can you hear me? Um,
I can hear you, sir.
okay, because I've been asking, because I'm not getting any feedback from you guys. So I thought maybe I'm talking and you guys cannot hear me. So we were just doing a recap on machine learning quickly before we could move to deep learning. Because if we don't have a good understanding on machine learning, we're not going to be able um, to move to deep learning and understand everything. All right. So before I start, is there any question? Anyone has a question so far on everything about AI so far, or any confusion? There's no wrong or right question. You know, you tell me about your challenge or your misunderstanding, so we can take it from there. Mathieu, is everything fine on your side? Okay. All right. All right, guys. So with machine learning, as we all know, machine learning is just a field of AI which has to do with all the research for creating all the algorithm that will be used to create AI tools, right? And in machine learning, we spoke about how machine learning works. It means we're going to have to provide the data to the machine, create an algorithm to handle those data so the machine learn from historical data and the machine will have an understanding of that scenario and be able to predict the future. Just like human, we learn from experience, machine models will also learn from historical data. So we're going to give historical data to the models, and the models are going to learn from it. And the next time we bring a new input, the model, based on the experience they have with previous data, they will be able to give us a prediction, right? And then we spoke about differences between a normal type of programming and machine learning. Is that a normal type of programming, we explicit the rules are explicit, so the rules can be manually specified, so we specify to the machine what we want the program to do. But in machine learning, we don't tell the machine what to do, but we give machine data and we let the machine understand from the data and be able to give us future prediction. All right, and remember what we said in machine learning. What does it mean? We're training data by taking those data and loading them into the algorithm. Based on the algorithm, we're going to try and get a target function. But unfortunately, we cannot get a target function. After learning, we can only obtain a certain function that will be close to the target function. So, how do we call the difference between the target function and what we're getting? So, the difference between what we are planning to get or what we're supposed to get and what we are getting, how do we call it in machine learning? Let's say you're supposed to predict 100, but you are predicting 91 years. What does that 9 represent? Anybody? Actually, everybody. Everybody's supposed to know that. Anybody want to give it a try? Guys, give it a try. How do we call it? We have a target, but after the machine learn, we are not gonna get to the target, but we're gonna get to a certain value which is close to the target. So what's the difference between the actual target and the value we're getting? How do we call that? Who does not know? Who doesn't know how you called it? Yes, the leeway. How do you call that?
No, so I was saying I'm not sure because I'm still trying to catch up in terms of AI.
Okay, so that
I
is
missed a few
called,
classes.
yeah, that is called the loss. It's the loss or the error. We've mentioned that so many times to say when we training the machine learning, it's all about reducing the error for us to get the perfect result or a result closer to the perfection. So the difference between the value that we're trying to get and what we are getting is called the error or the loss. So basically, if you're trying to create certain things to obtain a number called 8, for example, but you are only reaching up to 7.5. So the zero point 0.5 that is left for you to reach the perfection is called the loss or the error. Okay, but in machine learning, when now remember the model itself that we're creating using the data, the model itself will be a formula. It's going to be a function. So because it's a function, even the loss will also be estimated in terms of a function. So we're going to have a loss function. And that loss function, using certain parameters, we can reduce that loss function. That's the whole point of machine learning. So when they tell you about machine learning, so the machine is seeing which uh, changes to do in order to reduce that loss function. All right. So we mentioned three main problems that we are solving with machine learning: classification, regression, and clustering. So in classification, the output of our the output will be a class or a category. So it's between the categories that we're going to give. So that's a classification, and it's usually used when we have what you call that supervised learning. That means when we're training the data, we're providing data that are labeled, data that already have output. So the machine knows exactly what it is. So classification, you think about it, for example, you're trying to look at pictures and determine if it's a picture of a man or a woman. So you have two classes, male and female. So that is a classification problem. When we talk about regression, regression is when we're solving a problem where the output can be any value. For example, to determine the age of people who are allowed to drink by looking at the data that we have and determine. So it can be any number. So you can't really put it in terms of a category. So that is a regression problem. And the clustering problem is when we have a large amount of data which are unlabeled, so we don't know what those data represent, but we want to divide them into multiple categories based on the internal similarities, based on how they, uh, what's similar about those data. Okay, so that is a clustering problem. Okay, so in terms of the type of machine learning, how do we teach the machine? How the machine learn? It can be, we can use a supervised learning, unsupervised, or reinforcement learning. So when we're using a supervised learning, it means that when we give the data to the machine, we give data that are labeled. So the machine knows what type of data are those. For example, I gave you the example of the scenario of having to determine between male and female. So in this case, when you're training your machine, the data you're going to provide to the machine, if it's pictures, those pictures will tell the machine, these are pictures of male, these are pictures of female. So if we train the machine like that, we are using a supervised learning. But if it's unsupervised learning means that the data that you gave the machine, you did not tell the machine what are those data. So you let the machine itself discover certain pattern and create those patterns. Okay, so when we talk about semi-supervised learning will be in the case where some of the data are labeled, some are not labeled. And then we have reinforcement learning. Reinforcement learning is basically a system of training a machine by using an agent. So basically we use an agent, we put it in an environment, we create a reward and punishment function. So every time the machine take a good action, you give it a reward. If it takes a wrong action, you give it a punishment. And this is how you can train your machine. Okay. All right. So these are just examples. Okay, so the process of training a machine, we collect the data, we do a data cleansing. It means we clean the data, make sure we have the right data, and then we're gonna get the feature extraction. It means we choose which features we are using, what are we gonna use from those data, and then we can train the model, evaluate the model, and if there's any problem, we go back to the process, and then we can deploy the model as we use it. Okay, so remember now what is a data set? The data set is just the data that we have. We call it a data set. And every sample that we're going to use to train the model with, we're going to call it a training set. And whatever we're going to use to test the model, we're going to call it a testing set. Okay, so why is it important to do a data processing? To avoid data dimension, to avoid a data, how you call this? To avoid the dimension explosion. So we don't want to have so many data and destroy our model. So we have to do a data cleansing and all those pre-processing that, okay? So when we talk about dirty data, it means we have data that have any type of inconsistency. And then we have to make sure that now to get the right features. The features are the type of information we need from the data. Sometimes you have so much data, but some features are not important to the type of scenario you're working on. So there is many methods that can be used to get the right features. So we have, for example, the filter method, the wrapper method, and the embedded method. Okay, so what else have we done? And remember, guys, even in the classification problem, what we're gonna have, the prediction will come as a probability, and then from that now it's gonna classify it into the class with the highest probability. Okay, so we spoke about overfitting, underfitting. What else? Okay. Okay, other key methods. The method we spoke about, the gradient descent, which is just a method that we use to reduce the loss. Remember there I told you what is a loss, what is a cost. It means the difference between what we're trying to obtain and what we are actually obtaining. So now to try and reduce the loss, and because we use certain method called, you have, for example, the gradient descent. So the gradient descent, remember guys, yesterday I even showed you a video where they were trying to detect the handwriting digit, where you have the weight being assigned to everything. So the weight being assigned to every single input data. So that weight, we're going to be changing the value of those weight in order to reduce the loss. And to do that, we use methods such as gradient descent. So it keeps changing the value of W in order to reduce the loss. Okay. So we have different type of gradient descent. We have the BGD, which is the batch gradient descent, which will use all training samples for training each time. And then we have the stochastic gradient descent, which will just use one training sample for training each time. So one sample at a time. And then we have the mini batch gradient descent, which will use a certain group of samples at a time. Okay, and then we spoke about parameters and hyperparameters. These are settings that you have in your training. So these settings, parameters are those settings that will be learned by the model. So the model is changing, such as the weight is a parameter. But hyperparameter are all the settings that are set by, that are manually set, such as to determine how many layers you're going to have maybe in your neural network, or how many nodes, things like that. Okay, so you must remember that. Okay, so now in terms of hyperparameters, because hyperparameters are set by you, sometimes you may get the wrong values or get values that are not really helping you. So what do? We use certain methods that will help us get the right hyperparameters, such as we spoke about the grid search method, the random search, and heuristic intelligent search as well. Okay. Okay. Common machine learning algorithm. In terms of algorithm, we spoke about different algorithm. This will depend on the scenario you have. So you first identify the scenario that you have. Are you solving a regression problem, a classification problem, a clustering problem, or another problem? So if you're solving a regression problem, then you see amongst the algorithm, which algorithm will work well with your scenario. So you need to understand each algorithm and what it does. Okay. So we have linear regression algorithm. This algorithm is used mostly in a regression problem where the output will be any value. In this case, we have many examples that we can give. So basically, these are the data that we have based on the information they gave us. And the machine, using machine learning, we can create a function that is going to represent new input. So whenever you have new input, they may be able to give you an output. So, and then you have your logistic regression. So logistic regression is not used in regression problem, but it's used in classification problem. So the logistic regression will help us with binary classification. So problems where you even it can solve classification problem. That means that we will get a certain class from whatever result that we get from the output of this algorithm. So we're going to get one of the categories, okay? And then another algorithm we spoke about, yeah, this is just an example of using the logistic regression. So you need to note that the logistic regression will only apply when you have a binary classification problem. Binary classification problem, which means that you determine between two classes. But when you have a multi-class classification problem, you can use the softmax function. Okay, so this function will give you like a probability of, so you see the probability that you have to get, for example, this is an example, you want to determine the fruit. So the softmax function, it's going to give you an output of a probability. Like in this case, we have a 68% of this fruit being an apple. Therefore, the picture will be, the output will be apple. Okay. Another algorithm we spoke about is a decision tree. Remember the decision tree, the structure of it. We have a root on top, and then we have the features which will be used to divide the tree. Okay, that will represent what we call the internal node, and the output will be called the leaf node. Okay, so there's many ways of building a decision tree you need to look at. Okay, so another algorithm that we spoke about is the SVM, which is the support vector machine, which is also used in binary classification problems. So this algorithm will help divide the data into two classes. In this example, we're using to divide between women and men. So we can use that. So if you're dealing with a scenario where your output has to be a binary classification problem, then you can use the support vector machine. Okay. Right. And then we spoke about the KNN. k nearest neighbor. So this algorithm as well is used for classification problem, where we can divide data into certain classes based on the similarities of those data. An example can be this example, we want to determine between cat and dogs. We can provide data and the machine can see which data are closer to a certain group. So if we give a picture which does not look like any of the data, but the machine is going to look at the similarities and see which classes show that this has the highest probability of things. So basically, we have a new data here, and then the machine will look using the KNN. So if we have these two categories now, when we use KNN, KNN will look at these two categories and see the similarity and see this data is closer to these other data. So we're going to classify it as part of this data. So this is how the KNN work. Okay. And then another algorithm we spoke about was the naive bias. So the naive bias, called naive because it's an algorithm that quickly believes into certain things using just a few features. For example, you have a fruit which is red, it's round, and it's about 10 centimeters, and the machine will already predict it to be an apple. Okay. We spoke about ensemble learning, which is a method of building models by dividing data sets and creating many submodels. So you create many models, then you put them together to create the final model. So that is ensemble learning. So the many ways of doing ensemble learning, we have a bagging way or boosting. So with bagging, we have different algorithms which are ensemble learning algorithm created with bagging, such as random forest. And then boosting, we have example of AdaBoost, GPDT. Okay. So okay, let's now look at this case study. So, guys, so far, any question? Any question? I think I've recapped everything about machine learning. I've recapped everything about machine learning. So, any question? Any question on this? Because after this case study, tomorrow we're starting with Python programming. So, for those who are watching, those who are joining the meeting, or those who have a laptop, those who have a laptop, I will, if you want, you can have your laptop. I will show you what to, let me see, what can you download? Oh, it's fine. We're going to do it online. We're going to do it online so that you can do it straight from your computer. Okay. So any question? Any question?
Sir, I wanted to ask, so the way that these certificates are building up, they seem to build on one another. So can we say that they are leading to a particular title? Because data, we did big data, then we did AI. So essentially, are we like becoming data engineers or something if we gather all the certificates?
Now, the thing is, this, as you say, these technologies are working together because you're not going to use AI without data. So when you look at computer, what is it, cloud computing and big data, those are kind of complementary technologies that will be helping you with building AI tools. So it's mostly about AI, and these other technologies are supporting AI. So yeah, that's how it works. But you can specialize yourself in any of these fields, but when you are in AI, you understand the big data and understand as well the cloud computing, because you will have to use those technologies as well, depending on what scenario you're working on.
So then, sir, if I get all these certificates for cloud, can I call myself a cloud specialist?
You will, okay, how can I say it? No, I don't know why you need a title, but but each of these qualification is a qualification on its own. So basically, with AI, you're gonna have an it's called an HCIA AI. You have your big data. So you have all these certificates. So it's gonna depend on whatever you want to specialize on or grow on, but you already have these certificates. So they're independent, even if the technologies are crossing paths, but the certifications are independent.
Okay, so thank you.
All right. All right. So we're going to look at this case study, guys. I hope everyone can hear me. So, uh, so in these data sets, we assume that we will we have these data sets containing the house areas and prices of 21,613 housing units sold in a city. So you can see here we were given data. We were giving data information about 21,000, right, guys? We're talking about 21,000 data samples of houses that were sold in the city. So based on this data, we can predict the prices of other houses in the city. So can you see now? All right, so we're gonna see, okay, who's gonna tell us what is the scenario here? What is the scenario? Remember the four elements of AI, the scenario, which is the idea itself. So what are we trying to build? I think everybody can read that. Can anybody tell us? Can anybody summarize for us the problem that we have here? Our scenario.
So we are building a machine
Okay.
using supervised learning.
Okay, that is what you okay. This is you talking about the type of algorithm we're gonna use. Okay, no problem. But what are we trying to build? The machine to do what? What is our scenario? That's my question.
Say, are we not actually building a model that's gonna be able to predict the price of houses within the city?
Perfect, perfect. So we are building a model that is going to be able to predict the prices of houses in the city. So now, what type of problem we're solving? Is this a classification, regression, or clustering problem? Guys, it's a question. What problem are we solving now? Now that Nemfundo told us what is our problem is we're trying to predict the prices of houses in a city. So what problem are we solving?
I think it's a classification problem.
Okay, someone say classification. Anybody else? Anybody else? Deliwe, are you telling us something?
No, so I'm more inclined to agree with the classification.
Okay, anybody else?
It's, estimating house prices maybe based on property Areas.
Yes. Yeah. So the problem we are solving here will not be a classification problem. It will be a regression problem. Why? Because we are predicting the prices of houses. It can be any price. It can be any number. So you can't call it a classification problem, because a classification problem, you have to determine which classes you're going to determine. Unless they told us to predict if the houses are cheaper or expensive. Now we have two classes, cheaper or expensive. Then we will say we have a classification problem. But here we are getting prices. Can you see? It can be any amount. So we're solving a regression problem. Does everyone understand that?
Yes,
Sorry, can you
Yes.
just quickly revise what is regression? Because now that you said classification means that it must have classes. What
Yes.
does it mean to be in regression then?
Yes. Regression is when the output can be any value. So we can't put it in a class. We can't specify what's the class. So in a scenario like this one, the prices of houses can be any value. So you can't determine what will be the output. But when we have a classification, I have a system which has to detect the type of fruits that I have, but I've already taught the system to choose between mangoes and oranges. So that is now a classification problem, because the output is a certain category. But in this case, the output is not a category. Do you understand that?
Yes, sir.
Yes, so we're solving a regression problem. All right, so we now know what's the scenario. We know what problem we are solving. The third question will be, what features are we going to use? So what are we going to use to determine what is the feature? What features are we going to use? What features are we going to use?
Isn't it the area and the price?
No, wrong. We only, in this case, the price does not represent the feature, but the price represents the output itself. The price, this is the level. Remember what we're trying to predict here. Trying to predict what? The prices of houses. These are prices of houses in historical data. So we can't use these prices again and call it a feature. So the feature is the house area. So our input data, our features are only going to be the input area, and the output will be the prices. Okay, so we can consider these as X and Y. Y is the output. So these are the inputs. So in this case, we only have one input, which we're going to use to try and determine the prices. So now, as you've seen here, we have how many data? We have about 21,613. So now that is our data set, right? So remember now, that is our data set, which means that we can divide it and see, okay, out of 21,000, we're going to use maybe 18,000 for training, and the rest we're going to use it for testing. All right, so the way the model will work is that using the data set, based on the algorithm we're going to use, we're going to be able to create a model, which is a function, which means that next time now we're going to come with a new input, which is the house area. Using our model will be able to output what? The price of that house. So when you look at those data now that they gave us here, 21,000 data, when we represent them in a graph, we have this. These are the house areas, and these are the prices that it gave us based on those data. Now, can you see all these data? They are represented in different positions. So our model will be the function which represents this data in a way that every time we're going to input a new house area, which can be here, it's going to give us, if this function, we have this, you see, let's say this is the function that we got, which is a linear regression function, which will be W and that. So W1x plus that. Okay, so this function will mean that if we come with a new price, for example, 12,000, we put it in this function, it's going to give us the price, what price that it has to be. So the house area will be the value of X, our input here. And the output will be what? The price that we're going to get here. But now, what is unknown here? Can you see? Can you see? We don't know what is W1, what is W0. You remember we spoke about the weight and the bias. So the whole machine learning will run to find the right value of W1 and W0 in order for us to get a model that represents this data. So, because the question is, the model can be represented like this, like this, like this. So which one is the base parameter? So we have to find the learning. So we need to find the learning parameters W1 and W0. So the machine will learn and find this value by itself using a linear regression algorithm. So all these differences between what we're getting and what we're supposed to get is the errors. So what the machine will do now, we're going to use, now the machine is going to use the error function and try to reduce the error. Using which method? We use a gradient descent method. When we use the gradient descent method, the machine is going to try and get different values. You see, for example, here we have this one line here, and then the machine check the value of the weight is not really giving us the correct, it's not representing the data it gives. So these all are the part of the machine learning. So when we have, for example, this one, we still have an error of 201. The error is reducing. As the error reduces lower, again, we have a very small error. You can see the model is representing now the data that we have. So looking at that now, we end up with case what was used. We used a linear regression, and then we ended up with this function. So this was the value of W1, and this was the value of W0. So at these values, the machine has the smallest error. So now you have this function here. Every time you bring the new prices of houses in the new area, it put in this function, it calculates for you and give you the price. So this is the final model. So this is what we call a model. So a model is just a mathematical formula. In this case, the model was a linear function which represent this data. So using this model, we can be able to calculate the prices of houses in this area. Okay, guys? Is there any question on this? Any question before we can call it a day? Any question? Any misunderstanding? Any question? Or is everything clear? Was everything clear on this case, this study case?
Yes, sir.
Okay, perfect. So this is what we do. It's all about creating this function. So that's what the machine is going to do. So guys, regarding the recordings, I'm just I've downloaded all the videos. I'm just editing the videos and just to make sure I can upload all of them. I think by tomorrow we should have all the videos of big data and AI as well as we're moving. Okay, so just before we close, can we look at this quiz here? Okay, true or false, gradient descent iteration is the only method of machine learning algorithm. True or false? True or false, gradient descent iteration is the only method of machine learning algorithm.
True.
False.
Okay, so in this case, it's false because of the word only. It's not the only method. You also have ensemble learning, which is another method of in machine learning as well. So false. Okay, which of the following algorithm is not supervised learning? Which of the following is not supervised learning? Anybody? Which of the following is not supervised?
K-means.
Yes. K-means is an unsupervised learning. All right. All right, guys. Thank you very much. Tomorrow we're gonna start with Python programming. So we can see these machine learning principles. We can see them into coding. All right, guys. Maybe we can just take a screenshot of the class and then call it a day. Okay, guys. So thank you very much. I will see you tomorrow.
Quick questions, huh?
Okay.
In regards to the exam, I see on the group someone said we have until the 25th of July to write